Hi there. We're going to be getting started in a few minutes. We're going to go at 1 o'clock Eastern time. So we'll be getting started shortly. Let me know if you can hear me. That'd be cool. If you want to throw that in the chat, just let me know if you can hear me talking right now. There's only one person in here so far. We'll wait around a little bit longer and see if everyone joins. All right, cool. Thanks, Darren. Thanks, Joe. I think we're good to go. We're going to be going through some just some 3D drawing. It says advanced 3D. I think anytime you break into the 3D world, you kind of get into a bit of an advanced kind of thing. So we're going to look at a few of these create 3D functions. Excuse me, and kind of go through. We're not going to draw that exact part. We're going to draw something kind of similar. I did draw that part fully in BobCAD, but at this point, I don't remember any of the dimensions. So we're going to kind of wing it and kind of go through all those different things, because depending on how you build, you're going to subtract, you're going to add, you're going to do a bunch. So we're going to get started in about 5 minutes or so. Let everyone else get a chance to join in. And then if you guys do have any questions along the way, or there's anything specific you want me to go over, just let me know, and we can do that. So yeah, thanks guys. Be back in a few. All right. Good afternoon, everybody. We're about to get into this thing. My name's Mike. Today we are going to be going over some of the 3D CAD functions that we have inside the software to allow us to create things like what we see here. This part was done fully in BobCAD. I told some of the guys earlier, I don't remember all the things I did or the dimensions, especially for a lot of this. But most of it is all built using just a few different tools. When you start talking about Create 3D, you really have to start talking with Create 2D first, because most of the things you're going to create are going to start with wireframe and then they're going to go into making it 3D. So we're going to open up a new window here. So I'm just going to go to the BobCAD 1 here. And we're just going to start off with a shape. We're just going to kind of play this one by ear and kind of go with it. So we're going to go with our Create 2D, and then right here to the shape library. The shape library is a really good way of getting the basic shape of a part. I can't tell you how many guys I've worked with that all we're doing is simple flange plates, either on a plasma or on a mill or whatever they are. But instead of having to draw the whole thing, you can just use this option. I'm going to go with this little 5-hole flange here. So the way this shape library is going to work is you have an image right here, and in that image of the shape that you chose, there's going to be a bunch of numbers on it. And those numbers are going to represent and kind of tell us all the values or where these values need to punch in. So right here, we'll see that value number 1 is really the length of the part in X. So I'm going to go ahead and make that 5 inches. Number 2 is the height of the part in Y. So I could go ahead and make that 3 inches. Number 3 is the diameter of the center hole. I'm going to leave that at 1 inch for right now. Number 4 is the diameter of the 4 smaller holes. Number 5 is the spacing in X for the holes. So I'm going to set these at 4 inches. And then number 6 is the spacing in Y for those holes. So I'm going to set this to, let's say, 2.5. It's a little bit too much. Let's go 2 inches. So just like that. And then step number 7 is the radiuses on the corner. So if I want to change those to have 1/4 inch radiuses, or you can make a sharp corner plate by setting them to 0. Whatever you want to do, you just enter the values in. Now, what's great about using the shape library parts first and kind of starting with them is I didn't have to draw a rectangle. I didn't have to draw all the everything out. And if I made a mistake, so I'm going to hit OK. If I made a mistake while using a shape library part, maybe let's say that center hole is not the right size. Unlike the normal way of drawing where I'd have to draw all these pieces, if I wanted to change the size of that hole, I would have to come up to the arc command and put the right size hole in. But because this is part of the shape library, if you go to your CAD tree, you can actually kind of follow along with that feature. Now, most 2D features do not get added to the CAD tree. The only ones that I can think of off the top of my head are going to be anything you do from the shape library, and then the 2D Boolean feature also adds itself into there as well. But I'm just going to go to that shape library part that I made inside the CAD tree. And you can see right here's an edit option. You can rebuild. You can suppress and unsuppress. You can roll back your changes. This wouldn't be something we'd use on the first thing. And then you could delete the feature. I'm just going to go ahead and edit this feature. Now I can go into, let's say, number 3 here and change that to 2.5. And it's going to update. Now, I'm just going to hit undo one time. Let's jump into the 3D part of this and kind of see how those two go together really well. The first thing I always do before I go and make a solid model is I add a new layer. I know a lot of you guys don't use layers, or some of you guys don't use layers. Having layers to separate, especially solids and wireframe, is super important for me. It's the way that I keep my head in line and get everything moving the way, get everything flowing the way I want it to flow. So right here under the layers, if I right click, I'm just going to add a new layer. And as my caps locks on, I'm going to call it solid. So I make that layer prior to making my solid. If you forget to make your layer and then you create the solid and then you want to move it later, you can always move it. But the big thing that makes you kind of better at CAD is that planning ahead, kind of a few steps ahead at least. You don't have to know how you're going to get to the end of the drawing exactly from the start, but you do want to kind of plan it out. And I can tell you right now, hundreds and hundreds of times I've created wireframe and I've created a solid, and then later on I move the solid. It's honestly probably the normal way I do things, because when I'm planning ahead, that's just one of the things I don't think about. Now, normally if you make a solid and then you have to make a change to that solid, you have to undo what you did and rebuild it. But if you're using a shape library part, if I go up to Create 3D, talking about the most basic 3D tool that you can use, you're talking extrusions. Now, there is primitive shapes as well. Don't get me wrong. Primitives are there too. But when you're talking about modern day, usually making CAD, making solid models, extruding is the main way of doing it. You're going to extrude your solid. You're going to cut from that solid. You're basically building a solid and then taking away from it a lot of times, or adding to it, just depending on what you're doing. So in this case, I'm going to go with the extrude curve. Now, a lot of people will use extrude boss over extrude curve. And honestly, there is nothing wrong with that. A lot of guys here, even at Bobcad, they'll use extrude boss. For me, the way I always think of it is when I'm initially creating my solid model, I want to use extrude curve. That's going to let me create the extrusion. And then if there's anything I need to add or subtract from that, then I will use the extrude curve, the extrude cut or the extrude boss. Rarely do I ever use the extrude surface. It's just not something that comes into play. For me to do an extrude surface on a part like this, I would first have to go make a surface and then extrude it. When you see the word curve inside of Bobcad, we're specifically talking about wireframe geometry. So you're using wireframe to create that geometry. So we're extruding curves. Intersection curves is another example right over here. This allows you to take two solids that are intersecting each other and generate the wireframe off of the models where they intersect. It was actually the way that we used to a lot of times get the wireframe for lathe geometry back in the day. Now we have the Create 2D feature for spun profile that kind of speeds the whole thing up, and I don't have to add any geometry to do that. But anytime you see the word curves in the system, think of that as that's wireframe geometry. So we're going to start with an extrude curve. Now, anytime I break into the 3D part of this, I always like to change my view. Whether you're just rotating it by hand by pushing the middle mouse wheel down like a button and rotating, or by going up to your views and choosing one of the isometric views. Now, if you get a lot of part files from SolidWorks, if you're importing part files, a lot of SolidWorks part files are going to use the ISO 1 view. That's kind of their standard view. And for me, though, I like to look at it more like I'm machining it, is kind of how I always think of it. This tells me kind of more machining. That's part of this too. If you're just doing the CAD side of this, then you could draw however it makes sense. But a lot of times when I'm drawing something, I'm also thinking about how I'm going to be machining it as I go along. And this ISO 2 view right here is the view that I like to use. It's the view that anytime I set my stock wizard up and I'm defining the origin of my job, this is the view I'm going to go into. And you could shortcut that view by hitting Control on your keyboard and number 7 on the top of your keyboard. You can't use, if you got like a calculator pad on the right, you can't use that, but Control 7. And if you didn't know, Control 1 through 7 is all the different views. So you have your top, bottom, left, right, back, and front. And then Control 7 is your isometric view. And that's our default, which is, if you go into our list up here, our default is the ISO 2. I've also gone in and put the other one, the SolidWorks ISO. So ISO 2 right here. And then if I hit Control 9, I could go to ISO 1, just because I do get a lot of part files from SolidWorks. If you ever need to add a shortcut or you want to add a shortcut, it's real simple. You go up to just next to the undo button up at the top of the screen. You click that little button for the settings. And then you're going to go right down here to customize shortcuts. And so you go down to a feature that you'd want. So in my case, I went to ISO 1. And then in this box right here, you just hit the keys that you'd want to use. And in my case, this is already assigned to ISO 1, but you just hit the keys you want to use. The biggest thing is make sure you don't use a key that's already set for something else. It happened a long time ago. I actually don't know if you could still do it. I haven't tried it. But I had a guy that hit Control P, and that was what he used to activate select mode. And I don't know why he picked that one, but that's how he toggled select mode on and off. And some setting in his computer, when he hit Control P is a Windows active shortcut. Anything you're in, any web browser, anything you're in, if you hit Control P, it's print. I don't know how he had it set up, but it didn't ask him if he wanted to print when he hit Control P. It just printed. So his printer was in a separate room, and over the course of a few days, he hadn't gone into that room, and he had used Control P over, as far as we could tell, over 500 times. He put an entire ream of paper printed through his printer. And it ran out, and it still had a bunch of jobs that it couldn't print because it had no more paper to do it. So if it has an assignment, do not use it, all right? You're going to just say, because we're not going to tell you. Control P is a Windows function. We can't override that. Same with Control S. That is one that is a Windows proprietary. I mean, that's one of their shortcuts. We do use it. If you ever want a shortcut, hit save, just hit Control S. And so you always just want to make sure you're not accidentally doing something that you're not supposed to. So most of the time, if I know it's an empty value, like Control 9, I know there's nothing for that, I can use that. A lot of times, though, I'll do like Control Alt S. And that'll be, in my case right there, select mode. I've already had that one set up. So that when I'm not inside my feature, I don't have to go up and click this button. I just hit Control Alt S and turn that select mode on and off. So that's shortcuts. They're very, very handy. So if you can use them, use them. So right here with our extrude curve, the first thing we'll notice is there's two distance boxes. And with extruding, you can extrude up and you can extrude down. Now, it sounds like that's all it is, but it really depends on the orientation of your geometry. If the normal direction for my geometry is along the z-axis, then we're going to go up and down. If the normal geometry for me is along my x-axis, so basically take the part and rotate it up so it's sitting this way, you're going to extrude along the x. Bobcat is smart enough to figure out which direction we should be extruding. When we do this, we set our distance going up and our distance going down. So distance up, distance down. And you could also add a draft angle. Now, one thing to take note of, when you're doing a distance going down, you do not need to put a negative number. It won't actually let you put a negative number, but you don't need a negative number. And the reason is we're just asking you from this point downward, how far are we going? It's the same as if I told you to go dig a hole. We don't have to specify that it's negative 6 feet deep. We just say, go dig a 6-foot hole, and you know what it is. So I'm going to start by just picking my geometry, just like that. Now, if this was as simple of a part as I'm making, I would not use a positive direction going up. I would usually use an other direction to bring it down. So let's call it, this part's 1 inch thick. All right. Now, part of this also links into the machining side of this. Where am I going to zero out my tools from? Am I zeroing out from the top of the part, which is on a mill how I'm most likely going to do it? But if I was using a router, a lot of guys with routers don't use the top of the material. They use the spoil board, and they'll set the spoil board as the origin. So that's kind of my deciding factor here on whether I extrude this part up 1 inch or whether I'm going to drop it down 1 inch. So it just, for me, is going to depend on how I plan on machining it. So I'll put a 1 right here. By having a value in both boxes, we now have 2 inches. Our part's 2 inches thick. And so we have that. I'm going to zero out the top distance there. And now we have a 1 inch thick part. The top of it is sitting right at XYZ0, or let's say Z0. And then we're going down 1 inch. The draft angle is the angle for the walls. All right. So this lets me go in. If I say 10 degrees, it's going to taper it in. But you can run into issues like we see right there. There's no possible way to do this, or at least in this case, because I'm picking a piece of geometry that has holes and everything, the outside ends up getting tapered in and the holes end up getting tapered out. So realistically, if I had to do this, I would go and pick this piece of geometry and let it taper in. All right, so I can hit OK on that. And now I have a 10 degree. By the way, the draft angle can be a negative number. If you say 10 degrees and it brings the bottom of your part inward, well, minus 10 degrees is going to bring the bottom of the part outward. All right, so now I can hit OK. I'll leave it like that. And now I wouldn't want to add the taper to the holes. That's why we had to go back and repick the geometry. So now I can go in and say I want to do an extrude cut. And the extrude cut's going to let me cut these holes all the way through. So I'm just going to hit the letter S on my keyboard. Just the letter S. Just click it once. Don't hold it down or it'll flicker like that. Just one at a time. And I'm just going to go and pick all 5 of the holes that cut through this thing. Now, a lot of guys overthink this and they get real exact with this thing. Right now, I'm sticking up 1 inch. And I know that the distance going down is 1 inch. But what do I have to get rid of this top part? You don't. You can leave it right there. That top part's not intersecting with another solid model, so it doesn't really matter. My whole thing is I also never like going right to the exact size. I don't like to go 1 inch when I have nothing to worry about if I go over size. So I'll usually drag this through the part a little bit more so that I can ensure that I'm cutting. Let me go to that view. So I can ensure I'm cutting through the top and through the bottom by an excess. Again, if you leave it right at the edge, if it's not perfect and right just through the part, I've had times where I'll cut the hole in and there will be a sliver of material left on the bottom of the hole that then tells Bobcat that now we're doing blind holes instead of properly drilled holes. So there we go. I'm going to hit the letter S to turn that back on. And when we hit OK, it's going to cut through the part. So now I have my taper on the outside and I have all my holes. Well, what if at this point we realize I made that center hole too small? Well, what's cool is you can actually go back to this shape library. So inside the cam tree, you can right click on the shape library and say edit. And I can go and change number 3 to 2.5. And I'm just going to hit OK. And it automatically kind of runs through all the settings that we put in. So it reruns through the extrude curve and recreates the outside curve. And then we could use our extrude cut to come in and automatically change the size of the holes. So there it is. I want to get off of that view. There we go. So there we have it. We have a simple part that, we primarily use the shape library for. At this point, I would then look at what else do I need to do? What's going to be the thing that I need to add to this? Is it radiuses? Is it chamfers? What needs to be added? At this point, the holes and the center pocket that we have there, those are all 2-axis. We don't really have to get crazy with them. But the outside would have to be done with either a tapered tool, which you'd have to have the right taper for the tool, or you'd be using like a ball end mill to go in and rough it out. I'm going to go in and just add some fillets to this. Now, a lot of things that when you're doing fillets, a lot of times, especially on parts like this one right here is a good example of it. There's a bunch of different size fillets on there. But some of those fillets kind of link into other parts of our geometry. And so when you're doing your filleting, one of the actually best ways of getting the correct value, I'm going to go ahead and set this radius to 1/8 of an inch. And I'm just going to go start by picking edges. Now, where's my selections? That's selections there. Hold on, I've lost I'm in version 36. Yeah, I should have another option here. Hold on 1 second. Let me see something. There it is, the picking manager. So sometimes this guy will pop up on you. If you don't see it, it's a feature that doesn't need it. So I'm going to go back to my solid fillet command. And you'll see it disappears. I thought we added that for this one, but I guess not. So what I want to do here is I'm going to use my 1/8 inch radius. And I'm going to hover over this edge right here, just right on that edge. Then I'm going to right click. Did they really not do that? All right, never mind. Don't right click. I'll talk to them about that. I'm just going to pick my way all the way around, apparently. And at this point, we might actually have enough. It's got the tangent propagation. So if you pick multiple sides, it'll automatically make the tangency and connect it all together. But I usually pick everything. I'm also going to pick these holes here, right there. And then on this last one, on the center arc, I'm going to go ahead and change that radius to 1/4 of an inch. Now you'll see right here that all the geometry so far has had the 1/8 of an inch value. This one, when I add it in, is now going to have a 1/4 inch value. And if you did make a mistake, and I've done it before, where you have a bunch of size, you put all your fillets in, you drew them to the wrong size, and you're like, I need to change them all. Instead of canceling out and repicking everything, there's actually these parameters right here where you can change the radius and then say update the current geometry, which the current geometry is whatever you're clicked on in this window. Or you could say all geometry, and all these 1/8 inch values are going to automatically get updated to 1/4 of an inch. So I'm going to say, show me the preview, and there it is right there. Now, one of the things you could run into, if you were to do this with 2 separate filleting features, one of the issues you could have is that this isn't going to match up nicely. And you can see we're already kind of running into each other. But a lot of times when you do a fillet, sometimes it runs into another fillet. And if you do them separately, it doesn't have the ability to put the fillet. It's like the system can't figure out how to go from this to this. Now, that's becoming more and more rare. I will say that we are getting better with filleting. I've had less issues with it in these more recent versions, pretty much 34 up to 36 here, than I did in the past. I remember back in version 27, if you put a fillet in the wrong spot, you couldn't get it to cut properly. So, right there. One thing, let's go ahead and change this. Let's say the radius is 0.1875. Now with this one, I'd click on the fillet I want to modify and then say, do that to the current geometry, and just that one gets updated. And there you'll see we have our little fillet, and then we could hit OK. And so that's going to put little fillets on the part that either we're going to 3D machine, or we're going to come in with a corner rounding tool and machine them in. So there it is, little example of kind of a basic part. Other than the outside, you really don't need to, you don't need it for anything. This wireframe geometry, if I was just worried about getting the holes in the top of the part, that's pretty much enough. I just did a training earlier today, and that's what the guy wanted to do. He just wanted to make solid models out of wireframe. But everything he's doing is on a plasma. So everything he does is just a flat plate. There's no curvature to it, nothing fancy. So with him, all we did was do an extrude curve. We picked our part. We didn't have a draft angle, and we set it to something like 1/4 inch. And then that way he's able to take that part file, and what he does is he saves it as an STL file. And the reason he saves as an STL file is every computer, every Windows now has the 3D viewer. Or maybe mine doesn't anymore, I guess. Let's find out. 3D viewer. Yeah, here it is. I don't have it anymore, I guess. It was in Windows 10 when you bought Windows 10, but this right here, it's a Microsoft app. It allows you to watch or open up STL files and view them and look at them. And it's a pretty cool little feature of the system. And so if you're ever sending something to someone who doesn't have any CAD software to be able to view the part, that's a great option. They can't really do anything with it, but they'd be able to at least view it. They could rotate it. They could zoom in on it and actually get a good look at it. And saving as an STL is you're saving a fairly high quality solid model with it. So there it is. You got this one too. So if I was doing something like this, I probably wouldn't make this into a solid model. It's more work. But again, if you guys watch any of the Launchpad courses for the milling, where we do draw a few of the parts, almost every one of the parts I do turn into a solid model. And for me, the main reason I like having a solid model is specifically because of the simulation. So on this one, I have all my tool paths on the part. If I go up here and say start simulation, now there's two things that kind of apply to this. One is this workpiece option right here. My workpiece is my solid model, and the solid model that I'm looking at right now represents the final finished part. if you had some other features that, I've done many parts where I don't actually draw in everything I need. I draw in lines or small planes to be able to go and cut maybe a ledge on a part. So if you don't draw that stuff in or you don't have it fully represented, then I would not pick this as your workpiece. I wouldn't actually pick a workpiece. And you don't actually have to pick a workpiece. If I remove that, it's not going to cause any problems. The big thing here is we want to have this solid model load inside the simulation. And the trick for that really just is the layer that it's sitting on. If I add a new layer and I hide this CAD model, my simulation, when it loads up, is no longer going to have the option to see a workpiece. But if this model is on, when I click Start Simulation, give it a second. Right up here at the top, we can actually choose our workpiece. And we can say, I want to show my workpiece. And what that's going to do is it's going to take that model, which in theory, and the way we're trying to do this, that model should represent the final finished part. It's the part that if I could get that off the machine, we're golden. That's exactly what we want. For me, I'm just going to go ahead and hide that for right now. And I'm just going to fast forward through this whole thing. So we'll just fast forward through all of it. Right there. I'll give it a second. And there it is. So now that looks pretty good, but how good is that compared to the actual model of the part? Did I go small enough with some of these tools? Some of these tools got to be pretty small to get down into here. I can't remember what we ended up using for the pencil mills and stuff. But if I turn on the workpiece, what we see right now is exactly what I want to see with the results of any toolpath, whether it's 2-axis or 3-axis. I want the system to not really know which one to show me. Should it show me the stock or should it show me the part? The white that we see in there is the part. The blue is the stock. And so when we get into a situation like this, where when we look at this, the blue and the white are sharing the same, they're occupying the same space, then we know that they're pretty much in the same spot. Now, you can dive way deeper into that. I believe Eric went through it 2 weeks ago, where you go over to the analysis tab and you're going to set it up based on the deviation. Now, the deviation, let's go ahead and set this to automatic. Oops, set that to auto. So it'll set some much smaller values. And then a lot of times I'll come in and change it to manual, and I'll double click on these values to change them. So I could say, whoops, I doubled the decimal there. There we go. So 0.2 or 2,000, and then let's go 0.002 right there. And then so if it's green, we're within 4,000 of where we need to be. If it's cyan, we're leaving more material, and that material is between 2,000 and 26,000. So a lot of times I'll break these down quite a bit more. But the way this one works is after you do it, you'll hit this refresh button right here. And there you'll see it. So the spot that I kind of noticed right there, that is not cut as tight into that corner as it needs to be. It's between 2 and 26 thousandths. Again, we could adjust the range and it'll do it. If you see anything that's yellow, orange, or red, or any of these colors on here, that's parts where you're actually cutting into your part too much. I'm a lot happier about leaving a little material on the part than taking too much away, because I can't fix that. So this one might need a smaller tool to go in there and really clean it up. I'm not exactly sure. It's within, what I tested before, it's within a few thousand. So when I'm done with the deviation, though, make sure you turn it back to none so that the next time you load up a part, it doesn't have that. And there we go. So that's the main reason I like making a solid model that I could then use in my simulation. I can compare what am I cutting to what am I designing? What does my design look like versus what does the simulation show me that it's cutting? And if everything's good in the simulation, everything works out that way, then a lot of times that's I'm ready to go. I'm ready to post the code. If you're worried about moves happening incorrectly, things going the wrong way or anything like that, that's going to be more of something we definitely need to look at the post for. But at a point, simulating should be the thing that tells you this is what's going to be done. This is how we're going to cut the part, and this is how it's going to be done. But when your post is dialed in and you've run a few jobs with that post, what you see in the simulation should be what you see at the machine. And if that's not what's happening, let us know. Or if you need to add things to the post. I just ran into a guy the other day who wanted to just stop after his roughing. He roughed the part out. He wanted to stop. He wanted to take a look at it. And from that point, he was going to determine, do I want to go in and do a bit more roughing, or do I think the ball mill can handle what's going to come next? And so we were able to edit his post so that every feature always outputs an M00. I recommended against that, but that's what he wanted to do. So that's what we'll do. We put an M00 into his code. Every time a toolpath finishes, the machine automatically stops. So there it is. All right. Now, one of the things that I run into all the time working with guys is trying to build something from scratch. And I mean, you could have a print, but trying to build things from scratch. The way that you get something like these cutouts in here isn't by designing the wireframe and surfacing it, cutting it out. Those were literally just cubes that I used. I used some small cubes under Create 2D and I subtracted them. So sometimes it's better, instead of trying to modify the design to flow the way you want, you use something else to subtract from it. So let's look at that little piece at the top there. I'm just going to open up another new window here. And I'm just going to start by doing an arc. I'm going to go right there. And I'm going to make the diameter of it, we'll say 2 inches. And I'll hit OK. And then I'm going to just go right here to my Create 3D extrude curve. I'll pick that shape. I'm going to go down 1 inch, so down an inch, but I'm also going to have it taper out. So we'll say minus 10 degrees, so something like that. So now what I can do, and there's multiple ways to create a cube. It's really up to you how you want to do it. I could go in and I can create a cube from the primitive shapes. My issue with that is then I have to figure out where the origin's supposed to be. I got to figure out a bunch of stuff. So what I can do is I can go in and say Create 2D and make a rectangle. Now this rectangle could have a length of, let's say, what's a 1/2 inch look like? 1/2 inch, that looks great. So I'm going to go 1/2 inch by 1/2 inch, and I'm going to position it right at that 3 o'clock position over there, just like that. So now I can use the extrude cut feature to take that part and say, I want you to be, let's say, 1/2 inch deep. So I'm going to say 1/2 inch down and hit OK. And now I have that. Now, I can't tell you how many times I've gotten to a point like this where everything looks pretty good. That all flows pretty well. But then I go to try and put fillets on the part. And fillets don't go as well. Fillets can sometimes fail in certain spots. So sometimes you'll be in here working. Let's go ahead and set this to, it's going to be much smaller. Let's say 1/16 of an inch. I could go and pick all the geometry I'd like to fillet. This, and this one may not fail, to be honest. This one might be okay. Right there. And then we'll get right here and right here. And then say show preview. And you'll see it is going to do that. Let me hide that. Let's go that edge as well. There we go. So show the preview and it'll put it in. And then when you're ready, you can hit OK. I don't know what's up with this little guy right here. That's a strange fillet. But another way of doing that is to kind of put the stuff on the cube. So I'm going to go here. I'm going to adjust the size of that. Let's go to our Create 3D. Now the difference in this one, I'm going to go ahead and add a new layer and say, call it cutout. Instead of putting the fillets on the solid after we've subtracted the other solid from it, what we're going to do on this one is we're going to create the solid cube that we're going to have. We're going to put our fillets on that cube, And then we can subtract it from the model. So I can go up here and say extrude curve. I went a 1/2 inch before for the depth. I'm going to go a 1/4 inch up and a 1/4 inch down. Forget it. We'll go a 1/2 inch up and a 1/2 inch down. No taper. And I'm just going to go ahead and pick that shape. Now, this one lets me do it. What feature was I in before? Oh, the fillet feature. This one shows up with this picking manager. And some of you guys might get really annoyed by this picking manager because a lot of times it shows up right here. And for some reason, I am almost always picking geometry right where that box goes. Maybe different for you. What I've done is I took it right here. I grab it, bring it around with me. I'm going to go over to this measure entity or anywhere you want to put it. And you're going to drop it on the middle square right there. And that's going to add it as a tab right there. Now, this feature is fairly handy. For me, I don't find myself really taking advantage of it just because it's chain select. You're just selecting a whole chain of geometry. And I've been selecting chains of geometry for a long time now, just by holding shift on my keyboard and clicking on one of the lines for the geometry. So I'm just going to hold shift, or in this case, if that button is checked, you don't have to hold shift. If that button is unchecked, you will have to hold shift. But if I have this turned on, I could go here and pick that part just like that. And then I could hit OK. Now, while I'm here, I'm also going to go up to utilities and rotate. I'm going to pick that part and say, let's rotate one every around Z 90 degrees. Well, I don't need a tilde. So 90 degrees, but then I also want some copies. So I'm going to put 3 copies in. Actually, before we do that, hold on. Let's finish the other part of this. So I'm going to turn off my CAD layer now. So I'm left with just that rectangle cube thing. This is when I would go in and add my fillets to the part. So I'd go in and say create 3D, solid fillet. We'll set that radius to a 1/16 of an inch. And there's even a button called whole solid. So I can pick the whole solid, show me the preview. That looks pretty good. And then I can hit OK. Now, after I do that part of it, that is where I'll then go and rotate it around the part. So we'll go utilities and rotate. Let's do 6 of them if they fit. So 360 divided by 6. So 60 degrees in between each one. And then we want 5 copies. Remember, whenever you're doing your copies, if I want a total of 6, I have 1 already. So it's how many copies of that 1. We want 5 copies of that 1. And then I can hit OK and cancel out. And then if I turn on my CAD layer, there's all those parts. So now I can go into my Create 3D. And then this is where we can get into Boolean. So the way we did it before was by using extrude cut and then going in and adding all the fillets. And if I had to do that on 6 of these pockets, it would have been a lot more tedious than what we're about to do. So what this allows me to do is I'm going to go click on the top of Boolean. But if you click on the bottom, really any of these buttons that you see that have an arrow at the bottom, they have more options to them. If I click on planar, you'll see there's planars. There's also rectangular and circular planes. So it's just a flat plane that cuts through something at a certain distance. And then in this case, for Boolean, you can go add, subtract, or intersect. So add allows me to go in and add things together. And add and intersect are very simple. I'm going to just drag a box over this whole part. And then if I say show preview, if it all lights up as 1, that's good. And what actually happened here when it added it together was it absorbed the other half of these shapes. So it all becomes 1. Subtract is going to allow us to do the same thing. Let me go back into subtract. Subtract is kind of the same, but it's also different. There is a specific order I need to pick the geometry in. Now, for those bosses that we currently have standing up, there is no specific order I need to pick those in. When I go into the Boolean subtract feature, we have 2 boxes to input our geometry over here. The main solid or the surface body, which in my case is this shape here. This is the thing that at the end of the job, I want to make sure this thing is here in the configuration I'm building it for. So I pick that first, and then we go and pick all of the bodies that we want to subtract from that one. So I pick all 6 of these. And I could say show preview and then hit OK. So what that leads me to now is having, let me turn. hold on, let me just do this real quick. This is what I'm talking about. I should have put this solid on a separate layer earlier, but hindsight's 2020. I even said it though, and I'm just going to modify it to that one. All right, there we go. So now when I go to add my fillet, I don't have to add the fillet to the inside of this shape because I was able to do it real quick and easy with the part that's going to subtract. Now I can go in and do my solid fillet, and I'm going to go ahead and say the radius is, again, just a 1/16 of an inch. And I'll pick that top surface and say, show me the preview. And you'll see right there, we have all of that geometry. I could also go in and pick all these edges here. The tedious part about this is there is no fast way to, really speed up picking these pieces of geometry, but that's life. All right, that, and that. But I always like to do it as a group if I can. I want to get all that stuff in there if I can. So now let me say show preview. And you'll see that looks pretty good. I don't see any of the weird corners on there this time like we had before. Maybe it was just a visual thing. But yeah, now we'll hit OK. And we've just created that piece of geometry that we had there. Now that, like I said, may not be perfect for this part right here and what we got going on, but it's or at least it's not the same size, but it is very similar. Now, how about the bottom section here? How do we get that? Now, there's multiple ways to do this one. You could use, depending on the surface floor. I just worked with a guy last week that had a part kind of similar to this, more so similar in the center shape, except his was a perfect radius on his part. Not this one has a little flat floor and then it goes into a fillet. With his, he had a radius on the floor. And the way he did it was he had to calculate it, but he went to create 3D and he made a sphere. And so he was just able to go in and set up a diameter. And then in this case with the sphere, you can actually just raise it up. Depending, you really got to know what your radius is going to be. But if I said, what are we doing here? This is a 1 inch. So you see right there, the center of rotation moved up 1 inch. And now we're barely cutting into the part. But I could go in here and say, 0.75. That's now going to give me a 1/4 inch. But if I go much further than 0.75, now I'm going to start taking that sphere and kind of cutting it into where I want to be. We could also change the diameter a little bit, but I'm going to set this guy to 0.75 and then hit OK. And then once again, we would use the Boolean subtract feature to say, keep this, get rid of that, show me my preview. And now I can hit OK. And we have this radius down at the bottom. All right, give me 1 second, guys. I need to take a drink break. All right, sorry about that. Getting a bit parched. All right, so we can create it like that. I mean, and there's a lot of this, and I've been saying it for a long time now, but a lot of what really makes you good at this or gets you good at this is using it and just spending time with it. Even to this day, I still get stuck on what would look like sometimes simple drawings. I had one the other day. I was staring at that print for an hour until it all finally clicked into place, and it ended up being a 10-minute long drawing job. But man, the print that I had was just all over the place. I couldn't get right readings and everything. And we all deal with that. That's part of it too. So sometimes you just got to stare at it until it clicks in your brain. Or I've had drawings where I'll leave work and then either driving home or laying in bed at night, I'm like, oh, I know how I can do that part. I figured it out in my brain. And so I'll come in the next day and try and figure out how to make that all work. So yeah, using the software is how you're going to get better with the software. But there's a lot of features in here also that I could say most of us or most of you guys are not going to use. You're only going to use them in certain scenarios on certain things. One that I can point out right here, right now, that's on this page is sweep. Now, some of you guys might use sweep to create geometry. Most of us are not going to use sweep ever. The people that I've got currently using sweep, I had a guy this morning that's kind of designing a roll cage for some of the race cars that they're building, and so he wanted to kind of have a design of a roll cage and just see how Bobcat put it together. And we can do it. It's just really kind of time consuming versus some other softwares that are out there. But if Bobcat's all you got, it's what you got to do. And if you want to build a model or an assembly, we don't have mating like you do with SolidWorks, but you can still build an assembly and you can put things together and make it all work. But yeah, there we go. So yeah, a lot of these features as well, especially the specific surfacing features, all of us may not use those. And again, the reason a lot of us might not use them is because we never need them. If you open up a part file and it comes in clean and there's really nothing, if it came in with this quality that I have right here, which a lot of times the IGES, the STEP, the SolidWorks files, I don't run into too many issues. And again, our experiences could be different. I open a lot of part files from a lot of different places. And especially the last few years, I feel like it's gotten a lot better about opening the models and opening them correctly. I have a file somewhere on here that's from 2013 that when you open it up, there's missing fillets on it. And so you have to go repair those fillets before you can really start working on the part, or it's going to cause problems. Or in the case like this case right here, maybe that top curve that I have in there, this surface right here, I don't know how I'd machine that yet. I mean, I'd use a ball mill, but maybe I don't want to cut that right this second. Maybe I'll focus on that little thing later on. I want to, for now, just cut all of these things, or at least rough them out. If you don't know how to use any of these surfacing functions, then you're cutting that thing. Your advanced rough or whatever roughing tool path you're going to use is going to rough it. Basically, think of it this way when it comes to especially 3-axis. If the tool can fit, it's going to cut it. That's the reason some of you have probably experienced the 3-axis, I'll say the phenomena of you hit the button that says ignore holes and the tool goes and cuts the holes anyway. And part of that's because Bobcat doesn't really know what a hole is unless it was defined as a hole. And we didn't, when you're defining holes, a lot of us, like even in this situation right here, I didn't tell it that was a hole. I just made some holes that went through. I didn't tell it specifically it was a hole. Now, the reason that's slightly important, or why that matters, is depending on what you use to create the holes, Bobcat can tell that they're holes. And there's one right here called advanced holes. Now, advanced holes is a really cool feature for adding holes. I'm going to put one right here. Now, when you're talking about holes and using the advanced holes feature, you only need one piece of geometry. I mean, you could have multiples, but the piece of geometry is not an arc. You're not going to go and add in and tell it what size arc you're going to use. All you're going to use is a point. I am going to put a point. You won't see it right now, but I'm going to put a point right at XYZ0. And I'm going to do that just by hitting OK and then canceling out. Now, if I go up to Create 3D and I go to the Advanced Holes function, the only thing I'm allowed to pick in this scenario is points. But how do you know that that's the only thing you're allowed to pick? Well, this toolbar right here tells me. Your guys' toolbar, if you haven't changed it, it should default down to the bottom. I've moved mine to the left. You can change it by going up to your settings here. You're going to go down to user interface. And then the selection mask right there is I put it on the left. And I always like it on the left just because my monitor is wider left to right than it is tall. So I'd rather have all my stuff shoved to the left and the right if I could over that. But this is a really handy function that people ask about all the time. It's handy in the fact that it tells me what type of geometry I'm allowed to pick with this feature at any given time. Doesn't matter what feature you go into. Not every feature can use all the pieces of geometry. In this case, this skin surface, I can't pick points with this. I have to pick lines, arcs, splines, or I can use solids. Really, with that solid basket, it's kind of the edges of the solids that you could use to do it. But when you go to advanced holes, the only thing you're allowed to pick is points. So if they're lit up orange, you're picking points. If nothing is lit up, you're not picking anything. If everything is lit up, you're picking everything. And if one button is turned off, you're picking everything but that one button. All right. So I'm going to go to the advanced holes. I have my point right here, and you'll actually see I'm going to drag a box over this whole thing. Since it's the only point I have on my screen, it's the only one we can find. Now, when I'm doing this, I can actually go in and define all the specs about the hole I'm trying to create. So I could go in and say I want to put a chamfer on it. And this isn't, let me do this real quick. I'm going to cancel out of here. Cancel this. What's the best way? I'm going to do, I don't know how deep that sunk in because I just kind of eyeballed it. I'm going to go Z. If I say minus a quarter of an inch, what does that put me? Ooh, that puts me right on that. So I'm going to go minus a quarter, but I'm also going to go minus an eighth of an inch just so I can kind of get a visual of this. There we go. So when I go to my advanced holes now, if I pick this point, I can tell it to actually give me a chamfered cut in there. And what this does is it designs the hole, it designs the chamfer and the counter bore and all that stuff. Like I can actually add chamfers and counter bores, and I actually think I got to go higher. But when I hit OK, it's going to cut it into the part. Now that one failed because we weren't sticking out of the top surface, which is what I was kind of worried about. If I go with this one, though, we might be okay. Let's hit OK on that. Yeah, there we go. Now I've just designed a hole with a chamfer. That's going to be the tough part, getting that to start at the exact right spot. But I've designed a hole with a chamfer and a counter bore, and now Bobcat knows that that's a hole. Again, this, it might still cut. The tool can fit, it's going to cut it. So if you don't know how to fix that, if this is what I had, and again, I didn't want to cover this, the planer tool is there for that exact reason. You're going to go in, you're going to pick, say, the edge of the part like so, hit OK. And now when I go to machine this thing, I pick that flat surface that I just put on there as my surface. And now the system won't look at it. It won't see it. It can't see inside the part, so it's not going to look at it. The way you always think about machining is your tool is looking down on your part, down that blue arrow right there. So the tool is sitting here looking down, and you can look at it by going to a top view. If you can't see it in your top view, it's not going to cause a problem. We're not going to, like, if there's a problem on the bottom of the part, that's fine. You know, it's not super common that I get it, but let me unstitch this solid to surfaces real quick. But I have had parts that show up and they're essentially just a shell, like so. You know, I'm now missing a complete surface. That's the geometry I have. But if I rotate this around and I go to the top view, basically where the tool's looking at it from, there's no issues there. There's nothing in the way that's going to cause me any problems because that surface that's missing is on the bottom. This thing would machine totally fine. Let's go ahead and delete that guy. Yeah, so all that would work. Again, I don't like working on files like that. I prefer that when I have things, I'm going to get rid of that one plane or two. When I have a solid model, I want that whole thing to light up into one piece and work. All right. Any questions so far with any of this stuff that I'm going through? You should have a chat. I think it's on the side of the screen. You can click. There's a chat button. I don't know where it is anymore. I was there 2 weeks ago, but I don't remember anymore. All right, we will continue on then. So the other thing that we have, I mean, let's talk more about some of these other functions up at the top. One that's seldom used but has been a big help for me, and I want to say it's how I created this surface right here, but I can't 100% remember if this surface. So if we look at this from this view, there's a curve to the top of that surface. All right. So the way that I did this, looking at this now, And this thing, that part was all on the fly. I made it for videos so that I could shoot a part that looked pretty cool. I went to the shape library. I'd say I probably went right to this guy right here, the little plus sign. And all I'm going to do is say, let's make it 3 by 3. Let's go 4 by 4. Forget about it. And then we'll do 2 inch, 2 inch. That looks all right. Let's go. Let me do one thing. Let's go 1.5, 1.5. Yeah, she looks pretty good. All right, so I'll hit OK. I'll take that. So now using this shape, I can create the kind of wireframe I need for it. So what I'm going to do is I'm going to use that shape. And if we look at this, there is a taper on the wall. All right, so I'm going to start by going to right here. I'm going to create 3D, and I'm going to use the extrude curve. I'm going to drag a box over the whole part, and I'm going to say, give me a 10-degree taper like so. And you'll see that the top tapers into the bottom. All right, we add that taper upwards. All right, so I'll hit OK and then cancel out. So now what I'm left with is, I got the taper on there, but how do I get this thing to curve around here? Well, the first thing I'd have to do is kind of define the curve that I'm looking for. And that's a little bit easier said than done because I don't really know what size sphere to use, but I use a sphere. Let me say a 2 inch. Actually, let me say the diameter is 4 inches. We'll go bigger, 6 inches. So something like that. Now, in real life, I would try to be real good about this, but I'm just going to drag this down until it just about connects to the corners right there. We'll go up a little bit. Let's go up to minus 1.25. There we go. So we'll do something like that for right now. Oh, hold on. I should have put that on a new layer. So let's say sphere. S-P-H-E-R-E. There we go. And I'm just going to take that sphere and move it to that layer. That way I can hide it for a second. So now what I'm going to do is I'm going to add a new layer. I'm going to call it wireframe or whatever you want to call it. Wireframe may not be the best one. And I'm going to go to create 2D and I'm going to extract the edges off of this surface right here and then hit OK and cancel out. So now if I use the sphere and I use that surface, I can actually break the sphere from that surface. Now, the way you're going to break the surface from the sphere is first by projecting the wireframe onto the surface. So I'm going to say project curves. I'm going to say these are the curves I'd like to project. And then the surface that I'm going to use is going to be the sphere. Now, be aware of one big thing here. When it does this, it's going to project it up and it's going to project it down. So when I pick this, you'll see there's one of them. There's the other one on the bottom. So you end up with two of them. It's not a big deal. We're just going to hit OK and cancel out. And if I turn off the sphere once again, you can see we can delete the bottom one. So I can just go delete all that. And then I do have a bit of a gap that we'll see if we can mend that. I really could probably go down a little bit. Let's see here. If I was to do, let me do one thing real quick. Measure 2. I'm going to measure from that corner right there to that corner right there. 62 thousandths. I'm just going to go utilities and translate this, that whole shape. I'm going to go Z minus 0.062. And that should put the corners there. And then what I'm going to use is if I turn off the CAD, which has the solid on it, I'm just going to go in and delete, well, all this, all this, all this, all this, and then these arches right here. And that should, got a break right there. That should all connect together. So if I hold shift and click on this, the whole chain should start kind of connecting together. That should give me a little dome on top of this thing, just like so. Now, since I moved it, let me do this real quick. I'm going to hit undo. I'm going to take this shape here, and I'm going to say home copy. And then I'm going to go back to where I was. And just real quick, I just want to show you guys this part of it. Paste that there. And then I'm going to steal my sphere that I had. Copy that. And I'm going to paste it right there. So what I can do at this point is I can go to the Create 3D and I can break a surface. So what is the surface of the solid that I want to break? Well, it's this big old arc here. And what are the curves I want to use? I want to use all those curves right there. And when I hit OK, I can then go in and delete the whole bottom of this thing. And then just as an example, because this doesn't match up perfectly, but if I take that, I can go Home, Copy, New Window. I'll just throw this as a junk layer here. And I can go and paste it right there. And so that's the one that's going to be floating up above the part a little bit. I already have the wireframe now that I sunk down. So I'm hoping, and I'm not 100% sure what the best method is. I think we're going to go for a multi-sided patch and see how it works. It may not be perfect. I may end up having to do more than one, but we'll find out right here in a second. So I'm going to go to Create 3D and then multi-sided patch. Now, this is one of the ones that the new auto chaining thing, it's not a big help at all. So I'm going to turn that one off. Well, let's see. If I pick it, what does it do? Oh, because they're not all on the same Z level. So that auto chaining is set for constant Z. There's also tangent propagation, which may... No, that's totally fine. All right, forget about it. We'll leave it since it's all on the same Z level. If it was flat, it would auto-select everything. But basically with the 3-edge, 4-edge, and multi-sided patch surface functions, all we're going to do is pick the surface or pick the edges, the wireframe, in either a clockwise or counterclockwise manner. We want all of them to match each other. So a lot of times when I'm doing this, I think about that in the most basic of functions. If I think of this as the start point and this is the end point of this first line, I want to click closer to the end point. That's going to set the direction from the start to the end. So I'm just going to do that on all these lines. Basically, find the midpoint and go past it. Find the midpoint, go past it. I'm just going to click all the way around. I'm not holding any other buttons down. This button does it for you. So we're going to go there, 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 and there. And then I don't know if this is going to work or not. Failed. Okay, good. So it didn't work, which I guess not good. But what I can do here is a little bit more modifications. Let's see. Is there any other good feature for that? I don't think so. I think the way that I would go about doing this would be, I'm going to delete these two here. And I'm going to delete these two here. Just like that. And then I'm going to go to utilities and say trim one entity. And I'm going to try and take this entity and extend it to here. Take that entity and extend it to there. Oh, you're not going to extend, eh? From there to here, huh? Okay, that's fine. I'll fix that in a second. That one there. This one here. All right, so we're going to do another little trick to this. We're going to take that and delete it. And then we're going to go utilities and translate. And I'm going to say I want to translate this line here from the end of this to the end of this with a copy. Hit OK. I'm going to take this one here, and then I'm going to go from the end of this to the end of this, and hit OK. And so now I should have two shapes that match up. And again, I can't honestly remember if this is what I did when I made that original model or not. There's so many ways to skin the cat on this thing that, it's just, I don't remember anymore. But now I can go in and say I want to add a surface. So surfaces. Now, at this point, I could use, under Create 3D, I could use the 4-edge, and I could go and pick all 4 sides. And this one will probably work out just like that. But me personally, if I have a 4-sided shape, or 4 sides is really the one I run into the most, I don't use the 4-edge. I use the skin. which can be a little bit more tedious because you have to pattern it by doing one side then the other side. And then you have to switch boxes and do the other two sides. And the first two sides need to point in the same direction. So they both need to point north. The other ones both need to point east or west. They can point, the first ones can point south, but they both have to point south, is what I'm going to call it. Up, down, left, right. They all have to point the same direction. Where the 3-edge, the multi-sided patch, and the 4-edge, you're focusing more on clockwise versus counterclockwise, or clockwise or counterclockwise when you're doing this stuff. So I'm just going to hit OK there, and then I'll go pick this one real quick. 1, 2, 3, 4. Hit OK. They don't merge as nicely as I thought they would. It's because there's no curvature to that side. How did I do this when I made this? I definitely used a sphere, but I used a small chunk of this. I think I was just more accurate with my sphere cuttings. I think I was just more accurate with this. That'd be my guess. Let me go back to this guy real quick. Turn this off. Turn the junk on. Oh, not the sphere. I want the CAD. So let's do this real quick. Let's just go utilities and translate. And I'm gonna start by doing the pick option. I'm gonna pick this and move it right down to here. And then I'll pick my geometry right there. Turn that off, hit OK. So if I was to use this, let's just kind of go through this one. I can actually fix this edge right here. That can be fixed with a planar surface. So from here to here. And hit OK. And I'll put in a little surface to cover that patch right there to right there. Hit OK. I can go from here to here, hit OK. And I'll do the last one right here. That and that to that. And then hit OK. And then for these edges, you could use something like a ruled surface. Now, a ruled surface allows me to go in and say, this is one edge, this is the other edge, and it'll create a surface for that edge. Like that. And then I can go there to there, hit OK. And then instead of doing all of them, I'm just going to go to rotate. I'll pick those two surfaces, right? Ooh. Rotate. Try this again. I didn't get both my surfaces. That one and that one. And I'm going to rotate it around Z 90 degrees. And I'm going to add 3 copies to it. And then I can hit OK. So there we have it. So if I turn off my CAD, I'm left with something very, just like this. And that looks pretty good. The problem with this, and this kind of leads back to earlier, when you have a solid or when you have surfaces that aren't closed, we don't really care about that. I took the surface out of, where's that part? This one. When I removed that surface, I unstitched it. It's still machinable, but it's not editable at that point. You can't add that to another feature. You can't mess with that in any way. So what this allows me to do by going back to kind of this, I need to turn this into a solid that matches or is a closed shape. So I'm going to go up to Create 3D. I'm going to say Planar, and I'm just going to go pick the edges all the way around the outside of this. And it should be flat. And I could probably just extract the same wireframe I used before, but this should let me build this. There we go. Hit OK. Now what looks to be like a solid is, now we have what looks to be like a solid. And now I can go in and stitch it all together. So I could take this, pick this part, and then hit OK. That's now going to make it all one solid, as you'll see by just touching it. And a quick way to kind of verify whether or not it's a solid, if you go up to evaluate and you say measure 1 and you pick your solid. So you say pick solid, you click on it. Right over here inside your measure box is an option, is a feature called is solid manifold. Is solid manifold. And it's either true or false. If it's false, you're probably going to be unable to cut things into it. You're going to be unable to add things to it. But really what this means, it is solid manifold. Manifold is the correct term that for years you've been hearing me and a lot of the other guys here at Bobcat and a lot of places call a watertight solid. This is now a watertight solid. It's a good piece of geometry. So if you're ever wondering if you got a bad solid, measure one. Again, you got to make sure to turn on pick solid, but then pick it. If that says false, you're going to have a hard time with it. It's going to be a real hassle for you to work it out. But if I turn on my CAD layer now, I now have the top of that with that little dome. And if everything intersects the way I think it does, I should be able to go to Create 3D, Boolean, and add this and this together. So if you say show preview, if the part disappears, that's a bad sign usually. I think it's this corner right here. Oh, it's totally that corner. Oh, I didn't realize those were tapered. Oh, hold on. We got to cancel this. We got to get rid of this. Delete that. Yes. Turn this off. I'm going to undo the last bottom planar and then the rotate and that. So with this one, what I really need is better edges. What I really need is those edges. So let's do this. We're going to go wireframe 2. This is why I shouldn't name things wireframe, but I'm not good at naming things. So, all right. So with this one, I'm going to go to Create 2D and I'm going to extract edges. And I'm going to extract the edges from that surface there and that surface there. So I'll hit OK and cancel out. Turn this stuff all off. And then really, I'm going to go in and delete that for now, just so I don't confuse myself later on. These are the individual pieces I'm working on now. And so I'm now going to go in and add a line that goes from the center point of this down to there. And now I can go do the same rotate I did before. So Z90 with 3 copies. And that line should end up in the same spot for all of them. Then we could go in and this time I'm going to go with a planar. So I'm going to pick that and that. There's a good surface or a better surface. That one there and that there. Hit OK. And once again, rotate. I hate that this thing doesn't it resets every dang time. I've complained about it. Nobody cares. All right, hit OK. So now if we turn on what was called our junk layer and we turn on our CAD, this one I think we'll have better luck with once again. So let me go ahead and do my planar on the bottom. Yeah, ruled is a really great one if it works. But if it doesn't work, then it can sometimes lead to what we had going on was I think there was a small taper in that corner. We're about to find out, or none of this is going to work. And I got to figure out a totally different way of doing it, which is also totally possible. So there it is. We're going to put that on the junk layer. Should be able to hide that. Oh, nope. All right. So now let's go stitch this all together. So I'll stitch all this. Hit OK, cancel out. Let's give it a final shot and see if we can't Boolean add this. There we go. That is now going to turn into a solid. Did I not? Oh, yeah, there's a surface there. Okay. So, yeah, once again, we'll pick it, hit OK, and there is our solid. And from the top, it looks like a regular plus sign, but from the sides, it's got that curve. And this is much more exaggerated than the curve I did. But again, I think with this one, I used a much larger diameter sphere, and I trimmed it a little bit more on the edges. I can't remember at this point. It'd be something I'd have to kind of replan out and think about. But yeah, if I didn't use it in this video, it's probably not one that I use very often, to be honest. And we actually we tried to use the multi-sided patch. I rarely ever use that one. Skin is my main function that I use. I don't really ever use swung profiles or swung surfaces that are right here. We have some examples of them in the help system, and it's just not something that's ever really come into play for me. The main tools are going to be your extrude cut, extrude boss, and your, primitives, I'll give it that. Like I said, I don't create cubes. I don't create cylinders. What I use primitives for are spheres because they are more difficult to create. Cones because why not? It's an easy shape. and then Tauruses. But I don't use Tauruses very often either. So, yeah. Any questions that you guys might have? Anything that's sticking out to you? Anything that didn't make any sense? Yeah, this just has a nicer mate on that edge there. All right. Well, that's kind of it for today. That's kind of it for today. I got to get ready for some more training to do this afternoon. If you guys have any online training that you want to use, give us a call. Joe filled a lot of gaps of what I thought I knew. It's crazy what you think you know, right? I realized it the other day, or I realized it a long time ago, but a lot of people go into just something simple like the rotate command. And the amount of guys that actually don't know how that works it's staggering. Not that they don't get the right results, but they don't know how it works. And I was one of those guys for a long time. It was probably 3 or 4 years of using Bobcad before it really clicked into my brain about what that thing actually did and what I needed to do. I had a customer a few years back that called in needing help on rotate. This guy's one of our OGs. He's been with us for a long time. He was the first guy to ever buy the full 5-axis package and then use it on a 3-axis machine because he gets better control over surfaces on his finish passes. And he didn't know how to rotate. Every rotation he had ever done, when you go to rotate, you have to set the rotation center. But if your part is centered at XYZ0, you don't have to change anything. And so for however long he'd been using Bobcad, I want to say he started in 23. And so this was probably version 28, 29, maybe even into 30 or 31 that he called and he's like, I can't get this part to rotate. And I looked at it for 1 second and his part wasn't centered on XYZ0. It was up in the upper right-hand quadrant. And I showed him the rotation center point and blew his mind. There's a lot of little things that, I don't know. For me, they had to click. That click had to happen, and then it made perfect sense. Some are easier than others, like Mirror. I ran Mirror for years without actually paying attention to what I was doing. I was just looking at what the previews did. And now when I go into Mirror, if I want to mirror something, I look at which one I want. I can figure it out. But even then, a lot of times I'll still just click through these 3 options until the preview I want shows up. Surfacing, you're going to get burned surfacing if you're doing a lot of surfacing. But big tip for the surfacing, look at the pictures. All right, so if you go into skin right here, it's not the greatest of pictures, but it'll help. It's there to remind you that, hey, we're not going all the way around the outside with this. We're doing side 1, and then opposite of side 1, we're doing side 2. And then we're switching boxes and then doing side 3, and opposite of side 3, we're doing side 4. And a little other tip for you guys that are still here, there's only a couple of you left. If you have broken edges when you're doing a skin, do not put them in the cross-section curves. Put broken chains in the rail curves. You'll get better surfaces out of it, less breaks in your surface. That was a big learning experience for me. I was dealing with a bunch of broken, ratty little surfaces, and all it needed was a box switch, and that was it. So, all right, guys, it's been fun. I'll be here for a few more minutes. I'm just going to mute myself, and if you have any questions or anything, feel free to ask. And I'll just be hanging out for a few minutes, and then I'll let you know when I'm going to fully end it if no one's got any questions. So, like I said, there's a few of you guys left, so hang out for a minute, ask a question. It doesn't even have to pertain to this. If you got anything that you've been struggling with, let me know. Thanks, guys. Kyle, the filleting, it's hit or miss. It's I wish I could say that I loved our filleting, but there's definitely some things that could be better. There's fillets I've tried to slap on a part that just don't work no matter how I do it. I'm lucky enough that I have SolidWorks that's really good at stuff like that. But having fillets or putting fillets on a part, combining them together is a huge part of it. Doing all your fillets at once, changing the size while you're going through it has led for me to much better results than trying to do them one at a time. Because it's almost as if as they're getting created, they're figuring out how to blend into each other. As opposed to, I'm going to go put all my 1/4-inch fillets on, and then I'm going to try and blend these 1/8-inch fillets into those 1/4-inch. And that seems to be the part where I get where mistakes happen. It doesn't like to modify a fillet. And I don't know the exact science of it, but talking to our old head of development a few years back about filleting, fillets are a surprisingly difficult thing for computers to understand and do. Because every surface, every single line that you see in here, everything has an ID that's attached to it. And you guys can sometimes see it when you pick on a line. That's a chain. Hold on. There's some of the features. What feature would it be? Extract edges. Like, see how it's got edge 317-333. Those are the IDs of these edges, and they are. Essentially, when you fillet something, it has to figure out how to break this ID and then merge it with the other IDs around it. That was the basic that he told me. Apparently, it's just a really difficult thing for computers to do. And depending on what software you use, depending on how that's integrated, that can cause some of the issues. But like I said, try doing all your fillets all at once, kind of in one feature, and change the size in between. And yeah, you might have some much better luck. Otherwise, when you are struggling with that stuff, give tech support a call. We're always looking for more and more examples of these so we could keep throwing them at the development team and be like, hey, make this work. It works in SolidWorks. Let's make it work here. So yeah, send that kind of stuff into tech support. And, if they can't fix the issue, at least we can pass it on to our dev team and say, hey, make this work for the future. And it has improved drastically over the last few years. And that's mostly because you guys send in parts in and be like, this one didn't work. How do I make it work? And we'll get you some results. So. All right. Any final questions? I'll be here for about another minute, unless a question comes up and I'll talk some more. Otherwise, I'll let you know when I'm leaving. All right, fellas. That's it. I will see you guys sometime. I'm not sure. Eric usually does these things. He's on vacation this week. I'm sure I'll do one of these again in the future. If there's anything specific you guys are interested in seeing, email it to me, training@bobcad.com. And we can try and fit it into the schedule we got going. I don't know what the next one's on. They'll send that out, I think, next week. So yeah, thanks much, guys. Have a good one, and be safe out there.